A Russian tank with wheels bigger than a house crushed its own test pilot and then got stuck in mud forever. And that wasn't even the craziest weapon failure of World War I. Picture this. The year is 1914. The world just entered the most brutal war humanity had ever seen. Millions of soldiers are dying in muddy trenches. Military commanders are desperate. They need something, anything, to break the stalemate. So they start building weapons so insane, so completely unhinged, that even the people making them probably knew they were doomed to fail. We're talking about a gun so massive it could shoot a shell from Germany to Paris. A tank that looked like a tricycle designed by someone who'd never seen a bicycle. A flamethrower that was basically a giant firework that killed more of its own operators than enemies. These weren't just bad ideas. These were monumentally terrible ideas that somehow got millions of dollars in funding and actually got built. The thing is, World War I was the first truly modern war. Nobody really knew what they were doing. They were throwing everything at the wall to see what stuck. Machine guns were new. Airplanes were basically made of paper and wood. Tanks hadn't even been invented yet when the war started. So when some engineer walked into a meeting and said, "What if we build a tank with two wheels that are 40 feet tall?" nobody had enough experience to say, "That's the stupidest thing I've ever heard." And that brings us to our first magnificent disaster, the Tsar Tank. Imagine you're a Russian soldier in 1914. You're freezing in a trench somewhere in Eastern Europe. German machine guns are cutting down your friends left and right. Then your commander tells you that help is coming, a new superweapon that will crush the German lines and end the war. You look toward the horizon and see this thing. The Tsar Tank looked like someone took a massive cannon, strapped it between two carnival Ferris wheels, and added a tiny shopping cart wheel in the back for balance. I'm not exaggerating. The front wheels were 9 meters in diameter. That's almost 30 feet tall, taller than most buildings at the time. The whole machine weighed 60 tons and was supposed to roll over trenches, barbed wire, and probably small villages if they got in the way. The man behind this mechanical monstrosity was Nikolai Lebedenko, a Russian engineer who apparently thought bigger was always better. In 1914, he actually got a meeting with Tsar Nicholas II himself. Now, the Tsar wasn't exactly known for his brilliant military decisions, but even he was skeptical when Lebedenko showed up with his plans. So, Lebedenko did what any reasonable person would do. He brought a working model made of wood and clockwork. He wound it up and let it roll across the Tsar's carpet, climbing over books and other obstacles. The Tsar was so impressed, he immediately gave Lebedenko 210,000 rubles to build the real thing. That's about $10 million in today's money, for a tank that looked like a broken bicycle. Construction started in 1915 outside Moscow. The design team included some genuinely talented engineers, including Nikolai Zhukovsky, who's considered the father of Russian aviation. These weren't idiots. They were smart people who somehow convinced themselves that this thing made sense. The idea behind the giant wheels was actually not completely insane. Regular tanks, which were just being invented around this time, had a big problem with getting stuck in mud and trenches. The Tsar Tank's massive wheels would theoretically roll right over any obstacle. The high position would give gunners a better view of the battlefield. The intimidation factor alone might cause enemy soldiers to flee in terror. But here's where theory met reality, and reality won. The first and only test happened in August 1915. The Tsar Tank rolled out of its shed, managed to knock down a few trees, and then immediately got stuck. Remember that tiny rear wheel I mentioned? The one that looked like it came from a shopping cart? Yeah, that was the problem. See, the designers put about 60% of the tank's weight on that single small wheel in the back. The moment it hit soft ground, it sank like a stone. The giant front wheels just spun uselessly. digging the rear wheel deeper into the mud. The more the crew tried to get it out, the worse it got stuck. But that wasn't even the biggest problem. The Tsar Tank had another fatal flaw that nobody thought about until it was too late. Those massive wheels? They were basically giant targets. Any enemy artillery piece could hit them from miles away. And if even one wheel got damaged, the entire machine would be useless. It would be like trying to ride a bicycle with a bent wheel, except the bicycle weighs 60 tons and costs more than most people will see in their lifetime. The test crew tried everything to get it unstuck. They brought in teams of horses, they tried using logs and planks, nothing worked. The Tsar Tank sat there in that field outside Moscow for the next 8 years, just rusting away while the war ended, the Russian Revolution happened, and the entire country changed around it. Local farmers started stealing parts from it. Kids would play on it like it was the world's most expensive jungle gym. Finally, in 1923, the Soviet government decided they needed the metal for other projects and had it scrapped. The only evidence it ever existed are a few grainy photographs and the testimony of people who saw it and couldn't believe their eyes.
But here's the really crazy part. While the Russians were building their giant tricycle of doom, the British were working on something that actually worked. The first real tanks. The Mark I tank was ugly, slow, and broke down constantly. But it worked. It could cross trenches. It could crush barbed wire. It scared the hell out of German soldiers who'd never seen anything like it. The difference? The British tank designers started small and practical. They tested their ideas with prototypes. They learned from their mistakes. The Russians just went straight to building a 60-ton monster based on a wind-up toy demonstration. Now, you might think the Tsar Tank disaster would have taught everyone a lesson about over-engineering weapons. You would be wrong. Because while the Russians were watching their giant tanks sink into the mud, the Germans were building something even more insane. A gun so big, so ridiculously massive, that they had to build special railway tracks just to move it. The Paris gun. Even the name sounds like something from a bad science fiction movie. Picture a cannon barrel that's 34 meters long. That's longer than a basketball court. The entire gun weighed 256 tons. It took a crew of 80 sailors to operate it. Yes, sailors. The German Navy ran this thing, not the Army, because it was basically a battleship gun that they stuck on land. The idea was simple and terrifying. Build a gun so powerful it could shell Paris from German territory over 120 kilometers away. That's 75 miles. To put that in perspective, that's like shooting something from Philadelphia and hitting New York City. In 1918, before computers, before GPS, before anything that would make this remotely reasonable to attempt, the man responsible for this insanity was Fritz Rausenberger, a German artillery officer who looked at regular artillery and thought, this isn't complicated enough. The German High Command loved the idea, not because it was practical, but because it would terrorize French civilians and maybe force France to surrender. Here's how insane the engineering was. When they fired this gun, the shell went so high it actually left the atmosphere. It reached an altitude of 40 kilometers, entering the stratosphere where the air is so thin it's basically space. This was the first human-made object to reach the stratosphere. Not a rocket, not a balloon, an artillery shell. The barrel was so long that it drooped under its own weight. They had to support it with cables like a suspension bridge. Every shot wore away so much of the barrel's interior that they had to re-bore it after 65 shots. They actually designed shells of increasingly larger diameter to account for this wear. Shell number 1 was 21 centimeters. Shell number 65 was 24 centimeters for the same gun. The shells themselves were works of art. Each one was 2 meters long and weighed 120 kilograms. They had to be precisely manufactured because even a tiny imperfection would cause them to tumble in flight or explode in the barrel,
which happened multiple times, killing the gun crews. On March 23, 1918, Parisians woke up to explosions, but there were no aircraft overhead, no enemy troops nearby. The shells were coming from so far away that nobody could figure out where they were being fired from. The French thought it was some kind of new type of bombing aircraft flying too high to see. It took them days to realize it was artillery. The psychological effect was exactly what the Germans wanted. Parisians panicked. A quarter of the city's population fled. On Good Friday, one shell hit the church of St. Gervais during a service, killing 91 people and wounding 68 others. It was the deadliest single-shell impact of the entire war. But here's the thing about the Paris gun. It was absolutely terrible as an actual weapon. First, accuracy. Trying to hit something from 120 kilometers away with 1918 technology was like trying to hit a dartboard while blindfolded, drunk, and riding a roller coaster. The Germans were aiming for Paris, sure, but Paris is huge. They had no idea where in Paris the shells would land. They could be aiming for a military depot and hit a bakery 3 miles away. The gun could only fire 20 rounds per day maximum. Each shot took so much out of the barrel and mechanism that they needed hours of maintenance between firings. The crew had to calculate wind speed and direction for the entire 120-kilometer flight path, temperature at different altitudes, the rotation of the Earth. Yes, the rotation of the Earth. At that distance, the Coriolis effect meant that they had to account for the planet spinning beneath the shell during its 3-minute flight time. And for all this effort, what did they achieve? In total, the Paris gun killed about 250 people and wounded 620 others. That's less casualties than a single day of regular artillery bombardment on the Western Front. The gun cost millions of marks to build and operate. Each shot cost as much as a nice house. The entire gun crew could have been using regular artillery to actual military effect. But the biggest problem? The gun was so specialized, so precisely calibrated for hitting Paris from that exact distance that it was completely useless for anything else. When the Germans had to retreat later in 1918, they couldn't take it with them. It was too big, too delicate, and too slow to move. They destroyed it rather than let the Allies capture it.
The Allies never found the gun. To this day, nobody knows exactly where the Germans destroyed it or what happened to the pieces. All that money, all that engineering genius, all that effort, and it just vanished into history. The only evidence it existed are some crater holes in Paris and the testimony of people who couldn't believe anyone would build something so impractical. But at least the Paris gun actually fired. At least it technically worked, even if it was strategically useless. Our next weapon couldn't even claim that much. It was so dangerous to its own operators that it killed more friendly troops than enemies. The Livens Large Gallery Flame Projector. Even the name is a mouthful. William Howard Livens was a British engineer who had a personal vendetta against the Germans. His wife had been killed in a German air raid, and he wanted revenge. Not normal revenge, engineering revenge. He wanted to build weapons so terrible that they would make the Germans regret ever starting the war. His idea was simple in theory. Instead of using small, portable flamethrowers that had a range of maybe 30 meters, why not build massive underground flamethrowers that could spray fire hundreds of meters? Install them in tunnels under no man's land, and when the Germans attack, surprise! Suddenly the entire battlefield is on fire. The British High Command, desperate for anything that might break the trench warfare stalemate, gave him the green light. In 1916, Livens and his team started digging tunnels under the Somme battlefield. These weren't small tunnels, they were massive underground galleries, some running 60 meters toward German lines. At the end of each tunnel, they installed what can only be described as a giant flame-throwing machine from hell. The projector was a huge cylinder, 14 meters long and 2 meters in diameter. It held 2.5 tons of fuel oil mixed with gasoline. When fired, compressed gas would shoot this flaming liquid up through a pipe to the surface, creating a jet of fire that could reach 90 meters high and 300 meters long. The first test was at the Somme on July 1, 1916. 2 projectors were fired to support the British attack. The results were spectacular. And by spectacular, I mean spectacularly bad. The first problem was that the fuel mixture was too volatile. Several projectors exploded during testing, killing their operators. The tunnels would fill with fuel vapor, and one spark would turn the entire gallery into a crematorium. Multiple British soldiers were burned alive in their own tunnels before they even got close to the enemy. The second problem was wind. Nobody thought about what would happen if the wind changed direction while you were shooting a 300-meter jet of flaming liquid. On multiple occasions, the wind blew the fire back onto British positions. Imagine being a British soldier, thinking you're about to watch the Germans get roasted, only to see a wall of fire coming straight at you instead. The third problem was that the projectors could only fire once. After that, the entire mechanism was usually damaged beyond repair from the heat and pressure. So you spend months digging a tunnel, installing this massive device, and you get one shot. One. If it doesn't work, or if the wind is wrong, or if the Germans aren't actually in that spot when you fire it, you've wasted months of work and tons of resources. But the biggest problem was that the Germans figured out what was happening. They could hear the digging. They could see the tunnel entrances. They started digging counter-tunnels to blow up the British tunnels. It turned into an underground war with both sides trying to blow each other up before they could finish their weapons. The most successful use of the Livens projector was at Messina's Ridge in 1917. But even successful is relative. They fired 4 projectors and managed to cause panic in German lines. But the actual casualties? Maybe a few dozen Germans killed or wounded. For months of dangerous tunnel digging and tons of expensive equipment. Livens himself almost died multiple times. Once, a projector exploded while he was inspecting it, throwing him 30 feet and covering him in burning fuel. He survived but was hospitalized for weeks. Another time, Germans blew up one of his tunnels while he was in it. He was buried alive and had to be dug out by his team. By the end of the war, the Livens projector had killed more British soldiers in accidents than German soldiers in combat. The exact numbers were classified for decades because the British military was too embarrassed to admit how badly it had failed.
But here's what makes this story even crazier. While Livens was building his underground flame projectors, he also invented something that actually worked. The Livens gas projector was a simple mortar that could fire gas canisters at enemy positions. It was cheap, effective, and could be mass-produced. It became one of the most successful chemical weapons of the war. The lesson? Sometimes the simple solution is the best solution. But nobody learned that lesson, because while the British were accidentally setting themselves on fire, the Americans were building something even more ambitious. A flying bomb. In 1918, before reliable aircraft engines, before electronic guidance systems, before anyone had any idea how to make something fly in a straight line without a pilot, the Kettering Bug, also known as the Kettering aerial torpedo, was the world's first attempt at a cruise missile. And it was exactly as reliable as you'd expect a 1918 cruise missile to be. Charles Kettering was a legitimate genius.
He invented the electric starter for cars, the first practical air conditioning, and dozens of other innovations. But in 1917, he had an idea that was way ahead of its time. What if you could build a small, cheap airplane that would fly to a target and explode? No pilot needed, no risk to American lives. Just point it at the enemy and let it go. The concept was brilliant. The execution was a disaster. The Kettering Bug was a biplane made of wood and papier-mâché. Yes, papier-mâché, like an elementary school art project. It was 12 feet long with a 15-foot wingspan. It carried 180 pounds of explosives and was powered by a 40-horsepower engine that cost $40 to produce. The entire unit cost $400, which was incredibly cheap for a military weapon. Here's how it was supposed to work. Before launch, the operators would calculate the distance to the target. They would then figure out how many engine revolutions it would take to fly that distance. A simple mechanical counter connected to the engine would count the revolutions. When it reached the preset number, the counter would shut off the engine and release the wings. The bug would then plummet to the ground and explode. What could possibly go wrong with this plan? Everything. Absolutely everything. First, the launch system. The bug was launched from a track, like a roller coaster. It needed to reach 50 miles per hour to take off. The track was 60 feet long and pointed up at an angle. If anything went wrong during launch, you had a bomb on a stick heading in a random direction. During one test, the bug failed to gain altitude after launch. It flew straight along the ground at 50 miles per hour, heading directly for the crowd of military observers. Everyone, including General John Pershing, commander of all American forces, had to dive for cover as a flying bomb buzzed over their heads at tree height. It finally crashed in a field half a mile away, exploding and leaving a crater 20 feet wide. Another test saw the bug make a perfect launch, climb to altitude, then make a graceful turn, and head straight back toward the launching site. The entire crew ran for their lives as their own weapon tried to kill them. It crashed just short of the launching track, the explosion breaking windows a mile away. The navigation system, if you can call it that, was hopelessly primitive. The bug had no way to account for wind. A 10-mile-per-hour crosswind over a 50-mile flight meant the bug would miss its target by miles. During one test in Florida, a bug was aimed at a target 75 miles away. It was found 3 days later in Alabama, 200 miles off course. The counter system was even worse. It assumed the engine would run at a constant speed, but engine speed varied with altitude, temperature, humidity, and fuel quality. Sometimes the bug would fall short of its target. Sometimes it would fly past it. Sometimes the counter would malfunction, and the bug would just keep flying until it ran out of fuel. Out of 45 test flights, less than half even managed to fly in roughly the right direction. Several crashed immediately after launch. One flew in circles for an hour before crashing. Another disappeared entirely and was never found, presumably still flying somewhere over the Atlantic if it didn't crash into the ocean. But the military kept funding it because they were desperate. World War I was killing thousands of Americans every week. If this flying bomb could work, it could save lives. They ordered 75 bugs for combat testing in France. The war ended before they could be deployed, which was probably fortunate for everyone involved, including the Americans who would have launched them. The few bugs that were sent to France for testing all failed spectacularly. French farmers reported finding strange crashed aircraft with no pilots. One bug allegedly flew over Paris before crashing in a suburb, though this was never confirmed. Another was found in pieces across a vineyard, having evidently exploded in midair for no reason anyone could determine. After the war, the military continued testing the bug, hoping to work out the problems. They never did. The project was finally canceled in 1920, after 2 years of failures. The total cost was over $275,000, which is about $4 million in today's money. For that price, they got 0 successful combat missions and nearly killed their own commanding general. The Kettering Bug did inspire future weapons development. The V-1 flying bomb used by Germany in World War II was basically the same concept, but with 25 years of technological advancement, and modern cruise missiles are the direct descendants of Kettering's idea. So it wasn't a complete waste. But in 1918, it was just another example of technology being pushed beyond its limits. They were trying to build a smart weapon with dumb technology. It's like trying to build a smartphone with vacuum tubes and clockwork. The idea was sound, but the tools didn't exist yet. And speaking of tools that didn't exist yet, let's talk about the final insane weapon on our list, a German super tank that made the Tsar Tank look practical by comparison. The K-Wagen, or Colossal Wagon, was Germany's answer to British tanks. Except while the British were building reasonably sized vehicles that could actually move and fight, the Germans decided to build a land battleship. The K-Wagen was 13 meters long, 6 meters wide, and 3 meters tall. It weighed 120 tons. That's twice as heavy as any tank built during World War II. It had a crew of 27 men. Not 7, 27. It was less a tank and more a mobile fortress. The armor was 30 millimeters thick all around, which was impressive for 1918. It was armed with 4 77-millimeter cannons and 7 machine guns. The designers claimed it could reach a top speed of 7.5 kilometers per hour, which was optimistic to say the least. The design process was comedy gold. The German High Command looked at British tanks and completely misunderstood what made them effective. British tanks were successful because they could cross trenches and crush barbed wire while protecting their crews from machine gun fire. They were mobile shields that could get infantry across no man's land. The Germans looked at this and thought, the British tanks are good because they're big and have guns. So if we make something bigger with more guns, it will be better. This is like looking at a bicycle and deciding to improve it by adding more wheels until you have an 18-wheeler. Construction began in April 1918 at the Rebay factory in Berlin. They immediately ran into problems. The K-Wagen was so big it couldn't fit through the factory doors. They had to partially demolish the building just to get it out. The tracks were so heavy that they broke the factory floor. The engine, 2 captured Russian submarine engines bolted together, kept overheating and catching fire. The first prototype was almost complete when Germany started losing the war. As Allied forces advanced, the German High Command ordered the K-Wagen destroyed to prevent its capture. The workers at the factory, probably relieved they wouldn't actually have to test this death trap, cut it up with torches in November 1918, just days before the war ended. But here's the thing. Even if the K-Wagen had been completed, it would have been useless. The ground pressure was so high it would have sunk into any soft ground. It was too wide for most bridges and too heavy for the ones it could fit on. The turning radius was so large it would need a football field to make a U-turn. The crew arrangement was insane. The driver sat in a cupola on top, completely exposed to enemy fire. The gunners were spread throughout the vehicle with no way to communicate except by shouting or hand signals. The engine crew was in a separate compartment that would reach temperatures over 50 degrees Celsius. Several crew positions had no escape hatches, meaning if the tank caught fire, those men were dead. The Germans planned to build 10 K-Wagons. They thought these moving fortresses would smash through Allied lines and win the war. In reality, they would have been sitting ducks. Every Allied artillery piece would have focused on these massive targets. They were so slow that infantry could literally run faster. A single lucky hit to the tracks would immobilize the entire 120-ton machine. The K-Wagen represented everything wrong with German military thinking in World War I. They were so focused on making something impressive and intimidating that they forgot to make something that actually worked. It's the military equivalent of bringing a sword to a gunfight, except the sword is 40 feet long and so heavy you can't lift it. But here's what's really fascinating about all these failed weapons. They weren't idiots. The engineers who designed them were brilliant. The military commanders who approved them were desperate, not stupid. These weapons failed because World War I was a transitional period in military technology.
For thousands of years, wars were fought with muscle power and simple machines, swords, spears, bows, catapults. Then, suddenly, in the span of a few decades, everything changed. Machine guns, airplanes, poison gas, tanks, submarines. Military leaders were trying to fight a 20th century war with 19th century thinking. They didn't have computers to run simulations. They didn't have decades of experience with mechanized warfare. They were making it up as they went along, and sometimes that meant building a 60-ton tank with bicycle wheels, or a gun that could shoot into space but couldn't hit anything smaller than a city. Every one of these failed weapons taught important lessons. The Tsar Tank showed that bigger isn't always better, and that ground pressure matters more than wheel size. The Paris gun demonstrated that extreme range is useless without accuracy. The Livens projector proved that complicated weapons are often more dangerous to their operators than the enemy. The Kettering Bug revealed that autonomous weapons need sophisticated guidance systems, not just clockwork, and the K-Wagen taught that tanks need to be mobile, not just heavily armed and armored.
These lessons were paid for in money, materials, and lives. Thousands of hours of engineering work, millions of dollars in resources, dozens of deaths from accidents and malfunctions. But they were necessary lessons. Every failure brought military technology one step closer to something that actually worked. The really tragic part is that while engineers were building these elaborate failures, the most effective weapons of World War I were often the simplest. The machine gun, which was just a regular gun that fired really fast. Poison gas, which was literally just opening canisters of chemicals. Artillery, which had existed for centuries but was now mass-produced and coordinated. These simple, brutal weapons killed millions, while the wonder weapons failed in testing. There's also something deeply human about these failures. Faced with the horror of trench warfare, people wanted to believe that technology could provide a quick solution. A superweapon that would end the war in weeks instead of years. A magic bullet that would save lives by ending the conflict faster. This pattern repeated in every war since. World War II had its own share of failed wonder weapons. The Nazi sun gun, a giant space mirror that would focus sunlight to burn enemy cities. The British Pykrete aircraft carrier made of ice and wood pulp. The American bat bomb, which involved strapping tiny firebombs to thousands of bats and dropping them on Japan. Even today, militaries spend billions on weapons that don't work as advertised. The difference is that now we have computer simulations and decades of experience. We can usually figure out what won't work before building it at full scale. Usually. But in 1918, they had to build it to see if it worked. And when your weapon is a 120-ton tank or a gun that shoots into the stratosphere, finding out it doesn't work is an expensive lesson. The end of World War I didn't stop the development of crazy weapons. If anything, it accelerated it. The Treaty of Versailles put restrictions on conventional weapons, so countries got creative. Germany couldn't have an air force, so they developed rockets. They couldn't have tanks, so they secretly tested them in Russia. They couldn't have battleships, so they built pocket battleships that technically fit within treaty limits. The interwar period saw even crazier ideas. Death rays using focused radio waves, sonic weapons that would supposedly shake apart enemy aircraft, freeze rays that would turn enemy soldiers into ice sculptures. None of these worked, but people kept trying because the alternative was accepting that war would always be brutal and bloody. What's fascinating is that some of the failed weapons of World War I contained the seeds of future success. The Kettering Bug was a failure, but it pioneered concepts used in modern cruise missiles. The Paris gun couldn't hit anything useful, but it provided data on high-altitude ballistics that would later help develop space rockets. Even the Tsar Tank's failure contributed to understanding vehicle mobility and ground pressure. The engineers who worked on these projects went on to create actually useful things.
Kettering invented Freon and leaded gasoline, though those turned out to have their own problems. The German engineers who worked on the Paris gun later contributed to rocket development. The British engineers who survived the Livens project disasters went on to develop more practical chemical weapons, which is kind of horrible, but at least they worked. There's a temptation to laugh at these failures, to see them as examples of military stupidity, but that's not really fair. These were desperate attempts to end a war that was killing thousands of people every day. The engineers and military leaders who approved these projects genuinely believed they might save lives by ending the war faster. They were wrong, of course. The war ended not because of wonder weapons, but because of attrition. Germany simply ran out of men, materials, and willpower before the Allies did. The superweapons were irrelevant. The deciding factors were things like the British naval blockade that starved Germany of resources, the entry of fresh American troops, and the Spanish flu pandemic that hit the Central Powers harder than the Allies.
But people don't want to believe that wars are won by boring things like logistics and economics. They want to believe in game-changing superweapons. This desire drives military innovation, for better or worse. Sometimes it produces revolutionary technologies like radar or nuclear weapons. Sometimes it produces 120-ton tanks that can't move or flying bombs that attack their own launch sites. The legacy of these World War I weapon failures lives on in unexpected ways. Museums around the world display models and recreations of these magnificent disasters. The Tsar Tank has become something of a cultural icon in Russia, appearing in video games and alternate history novels. The Paris gun inspired science fiction writers to imagine even more extreme artillery, like Jules Verne's moon cannon. There's even a cottage industry of people who build working models of these failed weapons. You can find videos online of remote-controlled Tsar tanks rolling around, finally working as intended because they're small enough that the square-cube law doesn't doom them. People have built scale models of the K-Wagen that actually function because at 1/16th scale, the design problems become manageable. Modern military contractors still fall into the same traps. They promise revolutionary weapons that will change warfare forever. They get billions in funding. They build prototypes that don't quite work. They claim they just need more money to fix the problems. Eventually, the project gets canceled or scaled back to something more practical. The difference is that now, the failures are hidden behind classification and corporate PR. In World War I, when the Tsar Tank got stuck in a field, everyone could see it. When the Paris gun missed its target by miles, Parisians knew about it. Today's weapon failures are quietly canceled and forgotten, their details hidden in classified reports. But the fundamental problem remains the same. War is chaotic and unpredictable. Weapons that work perfectly in testing fail in combat. Simple, robust designs often outperform complex wonder weapons. The side with better logistics usually beats the side with better technology. World War I taught these lessons in the most brutal way possible. Millions died while engineers tinkered with impossible weapons. The real innovations that mattered were things like improved manufacturing, better logistics, and coordinated tactics. Boring stuff that doesn't make for exciting stories but actually wins wars. The crazy weapons we've talked about represent humanity at its most creative and most foolish. Faced with an impossible problem, breaking the trench warfare stalemate, people came up with impossible solutions. Giant wheeled tanks, guns that shoot into space, underground flamethrowers, flying bombs with clockwork brains, land battleships with crews of 27. None of them worked. All of them failed. But each failure taught a lesson, advanced technology a tiny bit, and contributed to the sum of human knowledge about what doesn't work in warfare. That's not nothing. It's not worth the lives lost and resources wasted, but it's not nothing. These weapons also serve as a warning. When military leaders promise that new technology will make war quick and painless, remember the Tsar Tank stuck in Russian mud. When engineers claim their wonder weapon will end conflicts overnight, remember the Paris gun killing random civilians while having zero strategic impact. When someone says they've invented something that will revolutionize warfare, remember that most revolutions fail. The truth is that war has always been and probably always will be brutal, chaotic, and decided by simple factors like who has more resources and better organization. Technology can provide advantages, but it can't change the fundamental nature of conflict. The search for a superweapon that will make war clean and easy is futile. But people keep trying. Right now, in classified facilities around the world, engineers are working on weapons just as crazy as anything from World War I. Laser weapons that will supposedly shoot down missiles, hypersonic missiles that can strike anywhere in the world in minutes, autonomous drones that will fight wars without human involvement. Some of these will work, most won't. And in 100 years, people will probably look back and laugh at our failures, just like we laugh at the Tsar Tank.
The cycle continues. Technology advances. Military planners dream of perfect weapons. Engineers try to build the impossible. Most fail. A few succeed and change warfare until the next innovation makes them obsolete. It's been happening since someone figured out that a sharp rock works better than a blunt one, and it will keep happening until humanity either gives up on war or gives up entirely. What makes World War I failures special is that they happened at such a unique moment in history. The Industrial Revolution had given humanity the ability to build almost anything they could imagine, but they hadn't yet learned the limitations of that ability. They could build a gun that shot into the stratosphere, but they couldn't make it accurate. They could build a flying bomb, but they couldn't control where it went. They could build a massive tank, but they couldn't make it mobile. These failures represent the gap between imagination and reality, between what we want technology to do and what it can actually do. That gap still exists today. We just hide it better behind corporate buzzwords and classified programs. So the next time you hear about some revolutionary new military technology that will change everything, remember these magnificent failures from World War I. Remember the Tsar Tank with its circus wheels. Remember the Paris gun shooting blindly at an entire city. Remember the Livens projector setting its own operators on fire. Remember the Kettering Bug flying back to attack its creators. Remember the K-Wagen, too heavy to move. Remember that for every successful innovation, there are dozens of failures. For every weapon that works, there are hundreds that don't. For every breakthrough, there are thousands of broken dreams and wasted resources. And maybe, just maybe, remember that the best military innovation would be figuring out how not to need military innovations at all. But that's probably the most impossible dream of all, even more impossible than a tank with 30-foot wheels or a gun that shoots into space.